When a function is given in the form of y is equals to f of x, for example, y is equal to the square root of 9 minus x squared, we usually say that this function is given explicitly. And for this type of functions, we can be able to differentiate them using the methods that we've discussed previously. For example, in this case, you can use chain rule to differentiate y is equal to the square root of 9 minus x squared. But sometimes you may end up with equations which are written in the form of x squared plus y squared is equals to 9. Now, when these equations are defined like this, we say they are defined implicitly. And therefore, this is the purpose of this tutorial, to find out ways in which you can be able to differentiate such equations. Now, for number one, we have x squared plus y squared is equal to 9, and we want to find dy over dx. The process involved is just to differentiate term by term. So from the left, you have to find the derivative of x squared plus the derivative of y squared, and then the derivative of 9. Now, for the derivative of y squared, you have to remember here that you have a function inside another function. So y is a function and it's squared. So we'll have to apply chain rule here. So anyway, so starting from the left, derivative of x squared is just 2x. The derivative of this, applying chain rule, we have to do outside, and then inside. Outside will just be 2y. And then inside, derivative of y is just dy over dx. And then here, the derivative of 9 will be 0. And then, of course, we have to rearrange so that we have dy over dx. So basically, if you bring this to the right, you'll have 2y dy over dx will be equal to negative 2x. And therefore, dy over dx will be equal to negative 2x over 2y, which will be equal to negative x over y. And that will be dy over dx for this particular equation, which gives the gradient at any point for this equation. Now, number two, we are going to apply the same process. So just remember that you have to differentiate each term one by one. So basically, starting from the left, you have to find the derivative. To find the derivative of x squared plus the derivative of xy, and then the derivative of 4. So the derivative of x squared will just be 2x. Now this is a product of two functions, x and y. So we'll have to apply product rule. So x multiplied by the derivative of y plus y, the derivative of x, which will be equal to 0 because derivative of 4 is just 0. So you have 2x plus x multiplied by derivative of y will be dy over dx plus here derivative of x is just 1, so we have y which will equal to 0. And then we rearrange this so that we want to have dy over dx on one side. So x multiplied by dy over dx will be equal to negative y minus 2x. And therefore dy over dx will be equal to negative y minus 2x over x. And that will be the required solution. Okay, number three. Again, same way, we have to differentiate term by term. So d over dx of x squared plus the derivative of y cubed, which will be equal to the derivative of 8. Derivative of x squared will be 2x. Now here we have to apply chain rule because you have a function inside another function. So you bring 3 in front and then y squared, and then derivative of inside, derivative of y is just dy over dx, and then you have 0. Now we have to rearrange this. So we'll have 3y squared dy over dx will be equal to negative 2x, which implies that dy over dx will be equal to negative 2x over 3y squared. Okay, moving on. Number 4. In number 4, we are required to find dy over dx for this particular equation. So here you have to find derivative of each term, just like what we've done, plus the derivative of x squared y plus the derivative of y cubed, which will become the derivative of 100. Now, the derivative of x will just be 1. Derivative of this will have to apply product rule here because this is a product of two functions. So basically, that will be equal to x squared multiplied by the derivative of y plus y multiplied by the derivative of x squared. And then for this case here, we have a function inside another function. We can apply chain rule. So that will be 3y squared. Derivative of y is just dy over dx. And that will be equal to 0. So here we'll have 1 plus x squared dy over dx plus a derivative of x squared is just 2xy, sorry, 2x, and then multiply by y, so 2xy, and then plus here you have 3y squared dy over dx is equals to 0. Okay, now the next step is to rearrange so that we have dy over dx by itself. So the plan will be, we'll group this together and then take this to the other side. So x squared dy over dx plus 3y squared dy over dx will be equal to 2xy. Sorry, that will be negative. Negative 2xy minus 1. And we can factorize dy over dx outside. So we'll have x squared plus 3y squared. All this multiplied by dy over dx will be equal to minus 2xy minus 1. And then what we can do here is to divide both sides by this so that we are left with dy over dx. So dy over dx, dy over dx will be equal to minus 2xy minus 1 over, and here we have x squared plus 3y squared. That will be the required solution.